going to do 3.2, which basically has to do with word problems where we're using systems of equations to solve. So, example 1, we start off with it saying the sum of two numbers is 10. Well, if we are talking about two numbers, we need letters to represent those. So down here we have our kind of a hint that says, hey, let x equal the first number, let y equal the second number. So the sum of the two numbers is 10, and we know that sum means addition, so we're going to have x plus y equals 10 for our first equation. The second equation is going to be a little tougher usually to find. It says if 3 times the second number, well, 3 times the second number is 3 times y, because y is our second number. It says is subtracted from 4 times the first number, and so that would be 4x. The result is negative 2. Well, if we're taking 3 times the second number and subtracting from 4 times the first number, we actually need to switch those around and make this 4x minus 3y equals negative 2. So, now I can solve this using substitution or elimination. You could solve it with graphing as well, but I wouldn't recommend it. Substitution or elimination would be easier. I'm going to eliminate because I can see here that if I multiply the first equation by 3, then that's going to give me a 3y, which will cancel out with the negative 3y. But I have to multiply the whole equation by 3, that whole first equation. So I get 3x plus 3y equals 30. 4x plus 3x is 7x. The y's cancel. Negative 2 plus 30 is 28. Divide on both sides. And then x equals 4. That's our first number, but it asks us to find the numbers, so find both of them. So we got to take this and plug it back in up here. I recommend into the first equation. It'll be the easiest one. So 4 plus y equals 10. So I subtract 4 from both sides. Y equals 6. So our two numbers are 4 and 6. Example 2, we've got a cost function and a revenue function down here. C is for cost, R is for revenue. And so it asks us on part A, find the number of units, which X is units. Find the number of units that must be produced and sold to break even. So when we break even, and we're talking about cost and revenue, the break even point is where those two things are equal. So what we want to do is we want to set 10,000 plus 16x equal to 26x. And so that means I need to subtract 16x on both sides. So that 10,000 equals 10x. Divide by 10. And I get 1,000 equals x. Remember, x is the number of units that are being produced and sold. And so for part A, our first answer is going to be 1,000 units. The second thing they ask in A is, at this level, what is the dollar amount coming in and going out? Well, that simply means if we're producing x units, which is 1,000, we need to plug that into one of our x's up here to find either the amount coming in or going out. And the revenue function will be easier to plug into, so let's pick that one. So all we have to do is do 26 times 1,000, which is 26,000. Now we're talking about a dollar amount, so this would be $26,000. Now on B, it says write the profit function from producing and selling X units of the product. And so we have this idea that P of X, which is our profit, equals R of X, which is our revenue still, minus C of X, which is our cost still. Revenue minus cost means that I need to plug in these functions from up above. Our revenue is the 26x minus our cost is 10,000 plus 16x. Well, since I'm subtracting something that has more than one term, this is like a -1 that I have to distribute. So 26x minus 10,000 minus 16x, because I'm distributing the negative. So that means 26x minus 16x is 10x minus 10,000. That is our profit function, p of x, and that's our answer for part B.
Example 3. Over the course of a week, a store sells a total of 230 cell phones. The revenue from these sales was $30,770. If one cell phone sold cost $99 and the other type of cell phone sold cost $199, how many of each type of phone did the store sell? So we have X is the number of $99 cell phones, Y is the number of $199 cell phones, and what we can do is we can say that together X plus Y has to equal 230. Then we can say, okay, well, if they made a total of $30,770, then $99 times the amount of phones that were sold for that much plus 199 times the number of cell phones sold for that amount has to equal that 30,770. Now this one wouldn't be too bad to use elimination on. It'll give you some big numbers, but we could do it. I'm going to solve this with substitution just to remind us what we would do with that, because substitution on this is easy since I can subtract y over to the other side or subtract x, whichever one, and now I can take this right here and plug it in where x is in my second equation. So 99 times 230 minus y plus 199y equals 30,770. I need to distribute and add like terms. So 99 times 230 is 22,770. 99 times negative y is negative 99y plus 199y equals 30,770. So I'm going to do this two steps at once here. I know that these are like terms, and together they'll give me 100y. I'm also going to move the 22,770 by subtracting it over to the right side. Because it doesn't have like terms, it's going to end up having to be moved over. So 100y equals, that comes out to be 8,000. Divide by 100 on either side, so y equals 80. So we sold 80, or not we, the store sold 80 cell phones at $199, and then we can plug this back in up here and get what x equals, because x equals 230 minus y. We know y is 80, so that's going to be 150. So that's 150 at $99. Those two are our answers. On example 4, it says you invested $2,000 into accounts paying 5% and 10% annual interest. If the total interest earned for the year was $160, how much was invested at each rate? Now, this word principal here in this chart, which is going to help us set this up, principal is the amount you invest. And so the total amount that we invest, we know that, which is $2,000. What we don't know is how much we put into each account. So let's put in letters right now, X and Y. For our interest rate, the 5% investment, our interest rate would be, as a decimal, 0.05. 10% would be 0.10, or just 0.1. Then our interest earned, what happens is that you take the principal amount, you times it by your interest rate, and that's your interest earned. So on the first one, x times 0.05 is 0.05x. Y times 0.10 would be 0.10y. And then in the very last column where it says total, it tells us in the problem that the total interest earned for the year was 160. And so what we can do now is set up two systems of equations. And so that means that x plus y equals 2,000. And then our second equation is 0.05x plus 0.10y equals 160. What you can do if you really don't like to have these decimals here is we can multiply this whole thing by 100 and get rid of those decimals. What it does is it moves all of your decimals over 2 places to the right, so this would be 5x plus 10y equals 16000. Well, now I can see really easily that to eliminate I would multiply the first one either by -5 or -10. So let's multiply it by -5. Get -5x minus 5y equals -10,000. And eliminate. 10y minus 5y is 5y. 16,000 minus 10,000 is 6,000. Divide. Y equals 1,200. And so that 1,200, our answer that we're saying is actually that we would invest the $1,200 at, since it's Y, the $1,200 is at the 10% investment. And then we need to plug in and find x. So I'd recommend going to this first equation. X plus 1,200 equals 2,000. Subtract the 1,200. So x equals 800. And so that means that $800 is invested at 5%.